In Lesson 02, you will learn many things. One of the things you will do is classify and graph real numbers. You will also write repeating decimals as fractions, and you will simplify and estimate square roots. Don't forget, you can pause this video at any time if it's going too fast for you. The first thing we have is a bunch of vocabulary words to help you understand this lesson. The first one is real numbers. Real numbers are the set of rational and irrational numbers. Rational numbers are numbers that can be written as a fraction a over b, where a and b are integers and b is not equal to 0. Irrational numbers are numbers that cannot be represented as terminating or repeating decimals. Terminating means ending. So we're talking about decimal numbers that do not end or repeat. Natural numbers are also called your counting numbers. 1, 2, 3, and the dots here show that it just continues on. Whole numbers are all of the natural numbers plus 0. Then integers are all of the whole numbers and their opposites. So you have 0, 1, 2, 3, and so on, but then you also have -1, -2, -3. A graphic to help you make sense of this is found in your textbook and is also right here. You might want to get this in your notebook. As I said at the beginning, real numbers are made up of rational and irrational numbers. Up until now and through middle school, you'll only be dealing with real numbers. It isn't until later where you're going to learn about imaginary numbers. Once you decide if a number is a rational number or an irrational number, you can then sometimes give it an even more specific name if it's a rational number. The way this chart works is that if a number falls here in the natural category, it's also a whole number, it's also an integer, it's also a rational number, and it's also a real number. If it's an irrational number, that number is also a real number, but nothing else. Now, one of the things that I always use to help me decide if it's a rational number or irrational number is if I can write it as a fraction. So if I have something like the number 3, I ask myself if I can write that as a fraction. And I can write that as a fraction like this. So therefore, it's a rational number. Once I know it's a rational number, I start to think about if it fits any of these other categories. Does 3 fall into the natural numbers? Is it one of our counting numbers? It is one of our counting numbers from our previous page. So therefore, it's also going to be a whole number, an integer, a rational number, and a real number. If I had something like this, can I write that number as a fraction? That is 25 hundredths. 25 hundredths can be written as a fraction. So therefore, it is going to be a rational number. Then I look to see if it's any one of those other groups within the rational number group. And it's not a counting number. It's not a whole number. And it's not an integer. So it would just be rational and real. Now if I took something like this, 0.3 repeating can be written as a fraction. 0.3 repeating is the same thing as 1/3. Since I can write it as a fraction, it is a rational number. However, it is not a natural, a whole, or an integer. So I would just say rational number and a real number. Now, if you come across a really crazy decimal that keeps going and going and going and doesn't repeat, that's one of those crazy numbers, or I should say it's one of those irrational numbers that I like to call the crazy numbers. A good example of an irrational number that you'll encounter a lot in math is pi. Pi is 3.14159 and even more if I had time. It's a number that goes on and on forever, and it does not repeat. Therefore, since it doesn't terminate and it doesn't repeat, it's an irrational number. The other time you will come across irrational numbers in math is often with square roots. Many times when you take the square root of a number, you end up with a really ugly number on your calculator that goes on and doesn't repeat. That's another time you're going to run into irrational numbers. If we take a look down here at these examples, 5/22. First thing I ask myself, can I write it as a fraction? Well, it's already looking like one, so it's going to fall into this group over here. And then I have to think about, is 5/22 any one of these special groups that are within the rational numbers? And it's not. So we're going to go ahead and just say it is rational. Now it's also real, but we don't need to list real because it already says in the question that it's a real number. Square root of 81. Now I know I said that square roots are often irrational, but if you take the square root of 81, square root is what number times itself gives you that number. The square root of 81 is 9. So when I take the square root of 81, I end up with this nice number, and I can write it as a fraction, so it is going to be a rational number. And then it is also one of our natural or counting numbers, which makes it also a whole number and an integer. The square root of 56, if you were to take the square root of 56, it's not going to be one of those nice numbers. It's going to be one of those ugly ones filling up your calculator. So that one is going to be irrational. The last example, -5, I can write that one as a fraction by putting it over 1, so it's going to fall over here in the rational number group. And then when I start looking at the other groups, it's not a natural number. It's not one of my counting numbers. It's not a whole number because of that negative sign, but it is an integer. So that one is going to belong to the integers and also the rational numbers. The next thing we're going to do is we're going to graph real numbers on a number line. -4/3, it helps me to think of that as a -1 and 1/3. Negative 1 and 1/3 means I'm going to be going to the left. I'm going to go to the negative 1, and then I'm going to go another third over. So that one's going to be right there. Negative 1/3, again, is going to be to the left of 0, and it's going to be 1/3 of the way between 0 and negative 1. 2/3 is positive, so it's going to be to the right of 0, and it's going to be 2/3 of the way between 0 and 1, so it's going to be about right here. And the last one, 5/3. Again, since that's an improper fraction, I'm going to think of that as 1 and 2/3 to help me place it on the number line. So we're going to go to 1 and 2/3, 2/3 of the way between 1 and 2. Now we're also going to be graphing inequalities on number lines. Before we can do that, we need to just quickly review that this is the less than and greater than sign. And if we have an inequality with the less than or greater than, you're going to put an open circle on the number in the inequality. The open circle means that it doesn't include that number, but then once we draw our arrow, it's going to include everything either to the right or left. If it has a less than or equal to or a greater than or equal to, we're going to use a filled in circle on the number because it does include that number, so we want to fill it in to show that it's included. So in this first example, if I want the numbers greater than negative 2, I want to go to negative 2 on my number line, and I'm going to put a circle. Now, since it doesn't include negative 2, I'm going to leave it open like that. Now I want the numbers that are greater than negative 2, and they go to the right. Those are the numbers greater than negative 2. B is less than or equal to 4.5. I'm going to find 4.5 on my number line. I'm going to put a circle on it. This time I'm going to color in the circle because of that equal sign there. We're looking for the numbers less than or equal to, which means it can include 4.5, so we color it in. The ones that are less than or equal to 4.5 are to the left, so we make an arrow to the left. The last one, h is greater than or equal to negative 3 and 2/5. You'll want to find negative 3 and 2/5 on the number line. So here's negative 3, and then 2/5 is going to be a little less than halfway between the negative 3 and the negative 4. And now I filled in the circle this time because it has the equal sign with it again. It's greater than or equal to. So we want the numbers greater than or equal to negative 3.5, so we want our arrow going to the right. If you have a hard time remembering the difference between greater than or less than, the symbol that looks most like the letter L, if you just squish it down a little bit, is the less than. And the one that you could creatively turn into a G is the greater than. Example 3 shows how to write repeating decimals as fractions. If you're really interested in the math behind how this works, you can look at the example on page P8 in your textbook. But for most of you, you're probably going to just want to look for the pattern that you see happening here. If I were to tell you that 0.1 repeating is equal to 1/9 and 0.2 repeating is equal to 2/9, 0.3 repeating is 3/9, which is 1/3, that would lead us to believe that 0.7 repeating is 7/9. If you have two digits repeating, such as these over here, the 1 and 2 are both repeating, then instead of it being over 9, it's over 99. So it's 12 over 99, 23 over 99, 27 over 99, which can be simplified to 9 over 33, or 9/33. This last example, 2 digits repeating, it's going to be 24/99. 24/99 can be simplified because both of these numbers can be divided by 3. 24 divided by 3 is 8, and 99 divided by 3 is 33. We're almost to the end. We're on to example 4. We're going to talk about perfect squares and simplifying square roots. A perfect square is rational numbers with square roots that are rational numbers. For example, 25 is a perfect square since the square root of 25 is 5. 144 is a perfect square since the square root of 144 is 12. Basically, when you take the square root of a number, it's what number times itself gives you that number. So here we have a list of some of the first perfect squares. This right here is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, and so on. Now when it asks you to simplify the square root, this right here really can be written as the square root of 7/16 squared, because 7 times 7 is 49 and 16 times 16 is 256. We also have a little negative out here, so we're going to put the negative here. Actually, if we back up a little bit, when you ask for the square root of 25, square root of 25, if you were to type that into a calculator, it would tell you the answer is 5. That's actually called the principal square root. But really, when you take the square root of a number, there's actually 2 possibilities. The square root of 25 is 5, and it's also -5, because -5 times -5 is also 25. But like I said, if you were to type in on your calculator the square root of 25, it's going to give you 5 as your answer. Here in this example, they want the one that's negative, so they put the negative sign in front of it. Now, if I want to finish simplifying this, the square root is going to end up being -7/16. Basically, you're taking the square root of 49, which is 7, and the square root of 256, which is 16. When we come down to this bottom example, this is really the square root of 2/11 squared, because 2/11 times 2/11 is 4 over 121. So if I take the square root or ask myself what number times itself gives me this, it's going to be 2/11. Now the very last thing we're going to do is estimate square roots. Sometimes, like I said earlier, when you take the square root of a number, it gives you this big, long, ugly number, an irrational number. And what we're going to do instead is just estimate to the nearest whole number what it's closest to. So if I see something like the square root of 15, 15 falls right here between the 9 and the 16. Remember, 9, the square root of 9 is 3, and the square root of 16 is 4. So the square root of 15 is going to fall somewhere between the 3 and the 4. But 15 is closer to 16 than it is to 9. So the nearest whole number is 4. The square root of 130 130 is going to fall right in between these two. 121 is 11 times 11, so the square root of 121 is 11. The square root of 144 is 12. Now you just have to figure out which one is it closer to. Is 130 closer to 121 or 144? Well, it's a little bit closer to 121, so the nearest whole number, the square root to the nearest whole number is 11. Now, that was a really long video today. Most lessons shouldn't take this long. Don't forget, you can always rewatch the video, or if you want another take on it, you can use the personal tutor in the online textbook, or you can always look at the examples in the book as well.